Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we are going to see the conditions for a molecule to be IR active or infrared active. That is, which of the molecules will show bonds stretching frequency values in infrared spectrum or IR spectrum. Okay, so these are some of the molecules that we are going to see. Okay, so how do we come to know whether a particular molecule is IR or infrared active or it is infrared inactive? So the concept is, we had seen in the last video that for a molecule or a bond to show stretching frequency infrared spectrum, that is to be IR active. What is the meaning of IR active? IR active means its bond will show stretching frequency in the infrared spectrum. We will get to see its stretching or bending frequency. So there should be a change in the dipole moment. This we had seen in the last video. Okay, that there should be change in the dipole moment of a particular bond. And when this is possible? When the bond is what? Bond is polar. When the bond is polar. Okay. But for a overall molecule to be IR active or inactive, what is the condition is? All the molecules, okay, all the molecules are IR active except homodiatomic molecules. Except homodiatomic molecules, all the molecules are going to be IR active. What is the meaning of this? All the molecules are IR active except homodiatomic molecules means homodiatomic molecules are going to be IR inactive. Homodiatomic molecules will be what? They will be IR inactive. Except these molecules, rest all the molecules are going to be IR active. These are what? These are IR inactive. Now, what is the meaning of homodiatomic molecule? Homo meaning same. Okay, di means two, atomic means atom. So, it is a molecule having two atoms and both the atoms are what? They are same. And what is the example of such molecules? Example is all the halogens. For example, fluorine, chlorine, bromine, iodine. Okay. Another examples is nitrogen, oxygen. Okay, these are some of the examples which are IR inactive. Okay, which are IR inactive. Why? And suppose you would say that this molecule is CO2, it is linear in structure, and if you draw the dipole moment, oxygen is more electronegative. How do you draw this arrow? Less electronegative to more electronegative. Okay, so this is one dipole moment, another dipole moment is this. So you would say that both the bonds are same. Okay, both the bonds are same, so this dipole moment would cancel out with other dipole moment. So this should be IR inactive. But is it IR inactive? No. Why? Because one of the mode will be IR inactive. Which mode will be inactive? That is, if I stretch this bond in this direction and in this direction, that is in the opposite direction, this is what? This is called as symmetric stretching. Okay, so you would find that the symmetric stretching, only this mode is what? IR inactive. Okay, but there are other modes of vibration that we have learned, right? Asymmetric or anti-symmetric stretching. Okay, anti-symmetric stretching, symmetric stretching, and there will be some bending modes as well, right? So these bending modes and anti-symmetric stretching, these are what? These are IR active modes of vibration. Okay, and asymmetric stretching and bending. I have written two times. Okay, and asymmetric stretching or bending, these are what? These are IR active modes of vibration. Okay, and now you would say, why in these molecules are these modes not present? The answer is no. Why? Because bending can take place only when there is a minimum of three atoms. Okay, three atoms must be present for bending to take place. So I hope you have understood this condition, that all the molecules are IR active except homodiatomic molecules. Okay, now let us see one by one all these molecules which are going to be IR. Let us first write down IR inactive. Okay, IR inactive will be homodiatomic molecule like fluorine, chlorine, okay, bromine, then I2, N2, O2. Okay, that's it. These are IR inactive molecules, and which will be IR active. All the rest of them will be IR active. That is, CO2 is IR active, then SO2 is IR active, methane is IR active, CCl4 carbon tetrachloride is IR active, carbon monoxide is IR active, and CS2 is also IR active. So all these are what? These are IR active molecules. Okay, so I hope you have understood the concept. Now let us solve this question. This was asked in JAM 2017 paper. It is a MSQ question, that is multiple select question. That means one or more than one answers are correct. One or more than one answers are correct. So we know which are IR. They are asking IR active. Okay, so is there any homodiatomic molecule that you can see? Yes, N2. So this is going to be inactive. Okay, remaining 3 will be active. Okay, D is incorrect. So the correct answers for this question are A, B and C. I hope you have understood the conditions to find out whether a molecule is IR active or inactive. Thank you.